Okay, so this is problem 8 and 9. I wanted to throw 8 in here. This is actually going to be like a no solution or undefined, and I just wanted to kind of explain why. So again, you have to check and make sure if you even can multiply two matrices if you're given a problem. And you have to check the dimensions. So this has 2 rows and 3 columns, so it's a 2 by 3. This also has 2 rows and 3 columns, so it's a 2 by 3. Now, these are the exact same dimensions, so I could add them or I could subtract them, but I cannot multiply because those numbers in the middle, right, the columns of the first one and the rows of the second one, these are not the same. Okay, they have to be exactly the same, and matrices are like a set amount of elements and information. Like, these cannot be adjusted or changed in any ways to make this work, so you can just say no solution or undefined, whichever works. So, and then you move on to the next one. So number 9, this is a 3 by 2 matrix, 3 rows, 2 columns, and this is a 2 by 2 matrix. So the columns of the first one match up with the rows of the second one. Okay, they're equal, so that means we can multiply. And whatever my answer is going to be, its dimensions are going to be a 3 by 2. Oh, well, there we go. 3 by 2. Okay, so that's what I'm going to do, or that's how I'm going to make my blanks. Okay, so 3 rows, 2 columns. Let's give it some space here. Okay, so remember the little trick. The number that I circled before helped us see if we can multiply these or not, but that number 2 actually tells me how many products I'm going to be adding on my lines. So each one of these lines is going to get 2 products because of that number. Okay, so we're going to be adding two things there. Okay, so again, go with the address. This is going to be used for its rows. Second matrix gets used for its columns. Okay, same way every time, rows and columns. This is row 1, 2, 3, column 1 and 2. So the address of our first blank, this is in the first row of this matrix, and it's in the first column of this matrix. So I'm going to take row 1 and multiply with everything in column 1. So that is 3, this 3 times this -1, and then add it to this -1 times 5. Okay, so then this spot right here, whatever element this is going to be, it is in row 1 and column 2. So I'm going to take row 1 and multiply it to column 2. So that's 3 times 6. And then add that to, we have -1 times 4. And then on to the next. So this one, this spot right here is in row 2, but we are in column 1. So I'm going to take row 2 times column 1. That's -3 times -1 plus 6 times 5. Okay, this is row 2, column 2. So I'm going to take row 2, column 2. That's -3 times 6 plus 6 times 4. Right here, we are now in row 3, and then this is column 1, so row 3, column 1, -6 times -1 plus -6 times 5. And then this last one, we are in row 3 and column 2, so row 3 times column 2. That's -6 times 6. Oops. And then -6 times 4. So again, that is the hardest part of doing all this. After that, you just have to multiply and then add your products together. But remember, you're just multiplying and then adding like what's on the line, because that is one number on its own. You don't need to combine that with anything else. Okay, so this is going to be a -3 and then I guess -5, so -8. Okay, be careful with your negatives. This is going to be 18 minus 4, so that's 14. This is negative 3 times negative 1, that's a positive 3 plus 30, so 33. Right here we have negative 18 plus a 24, so that's going to be 6. This is a positive 6, and then minus 30, so negative 24. Okay, that's going to be negative 36, and then minus 24. It's going to be negative 60. And that's it.